Hello everyone, welcome to Geography Session by Placers. Today's topic is jet stream. So what are jet stream? How the jet streams have been characterized? What are the reasons for the major jet streams on the world? There are two types of jet stream you can classify in troposphere. Some are permanent jet streams like tropical or westerly jet stream or also called as the polar jet streams. And next is some temporary jet stream like tropical easterly jet stream or African easterly jet stream or Somalian jet stream, flindlanter jet stream. These are all temporary jet streams. Now, what are the major mechanisms that can explain why the jet stream in upper atmosphere flows opposite to the ground and faster? And the second is why they flows parallel to the isobars or called geostrophic in nature. When these jet streams are moving, what are the impacts it can cause on the weather conditions, cyclonic, anticyclonic formation, or even it can explain the Indian summer monsoon, western disturbance, as well as the impact on the retreating northeast monsoon. Even the polar jet streams can explain an ozone depletion over Arctic and Antarctic. Why these ozone depletions increases in the winter season. Let's begin our session on jet streams then. Now, how the word jet stream has emerged. You know, during the World War II, the planes moving from the America to Japan, their speed appeared to be slowed down. And when the planes are moving back from Japan to US, the speed appeared to be increasing. So there must be something in the atmosphere that is pushing the jet planes faster when they are crossing the Pacific Ocean from Japan to American side. So that give rise to the fast blowing atmospheric wind that moves from west to east, and that's why these upper atmospheric wind which flows at the height of 12 kilometers is called as jet stream. Now, then a lot of research is being carried out on the characteristic of jet stream. So what has been discovered? It has been discovered that there have been high speed blowing wind from west to east. So on an average, it moves at the speed of around 120 kilometers to 250 kilometers per hour, but it can be anywhere between, we can call it from 90 to 500 kilometers per hour, and height at which they are blowing on an average is 12 kilometers, but it can be fluctuating in the altitude from 4 to 14 kilometers. So it has its own zigzag path it is flowing. And because of this meandering nature, they will have a characteristic called rose-by waves. Even these jet streams, most of the permanent jet streams move from west to east, which you can see in this diagram. And how does it is being characterized? They are characterized like a ribbon. You know, the ribbon has length and small width and small thickness. In the same way, the jet stream runs thousands of kilometers in length, cover the entire earth from west to east, and the width of 100 kilometers and thickness to 2 to 3 kilometers. Even the jet stream having a property that it joins again and again, splits again and again. So now what happened to the jet stream? So what has been special characteristics observed is that they flows parallel to the isobar. That's what we call most of the jet stream are geostrophic in nature. So how these geostrophic winds comes out, or how they able to flow parallel to the isobars? Because of the balance is being developed between the pressure gradient force and the Coriolis force. They become equal and opposite type. So let's explore the distribution pattern of jet streams in the troposphere. So there are two types of jet stream we can classify. One is permanent jet streams that found at 30-degree north and south, and second is 60-degree north and south. So those jet stream which is flowing at the 30-degree north and south called by the name subtropical westerly jet stream, and those winds that flows at 60-degree north and south called as polar jet streams. Okay, and there are many temporary, regional, seasonal or local jet stream exist. So what is the reason for these jet streams. Okay, or the reasons for temporary jet stream. Before going into the explanation, we try to explore the characteristics of temporary jet streams. You know, in India, during the month of summers, June till September, there is a wind which moves at the height of 14 kilometers called as tropical easterly jet stream. It crosses 15 to 20 degree north latitude. Why does it produce? That is the one question which comes to our mind, and what is the impact of it? Okay, it is not a permanent one. Second example of temporary jet stream is started from the Sahara Desert and moving to the West African coast called as African Easterly Jet Stream. It flows at the height of only 3 to 5 kilometers and found in the summer season. One jet stream started from Madagascar moving towards Ethiopian highlands, so crossing the equator called as flindlanter jet stream or cross-equatorial jet stream, also called as Somalian jet stream. Its height is also 3 to 5 kilometers. One special jet streams are observed at the height of 30 to 50 kilometers in the stratospheric layer called as polar night jet stream, also called polar stratospheric jet stream. So these jet streams, what is the reasons for this jet streams? So you have seen the distribution pattern of all the temporary regional seasonal jet stream. So this is tropical easterly jet stream, this is Somalian or cross equatorial jet stream or flindlanter jet stream, and this is African easterly jet stream. Now, what is the general reason for its jet stream occurrence, and why these acquire such kind of characteristics? So we know these jet streams are upper atmospheric wind which has been flowing at a great speed on an average 120 to 250 kilometers per hour. So it is a byproduct of interaction of two opposite type of atmospheric cycles. At the global level, there are three atmospheric cells: Hadley cell in the tropical areas, Ferrel cell in the temperate or mid-latitude areas, and polar cells in the higher latitude. So in these cells are interacting at two spatial locations, that is at 30 degree north is interaction between Hadley cell and the Ferrel cell, and at 60 degree this interaction of polar cell and the Ferrel cell. So because of this interaction, so jet streams get produced at both 30 degree and 60 degree. And the jet stream that produce at 30 degree we call the westerly jet stream, and that produce at 60 degree we call polar jet stream. Even there are jet stream which flows opposite to the ground winds, like in the polar areas opposite to the easterlies called anti-easterlies, opposite to the westerlies in the temperate areas as anti-westerlies, in the tropical areas opposite to the trade winds become anti-trade. These are also jet stream, but they do not flow parallel to the isobars. Okay. Now let's see the other atmospheric cycles like the Walker cells, which moves in the east-west direction because of the temperature difference between the ocean in the eastern and western part. Wherever the cold upwelling currents are there, that maintain high pressure, whereas warm downwelling currents are there, they are maintaining low pressure. So that maintain the Walker cell. So because of that Walker cell on the ground, Walker winds get produced. In the upper atmosphere, anti-Walker winds get developed. These anti-Walker winds are also we can define as a jet streams too. So now why these jet streams of different types which satisfy both the conditions? One, they flows faster in upper atmosphere and flows opposite to the ground airs. Second, they flows parallel to the isobars and become geostrophic in nature. So what is the reasons for it? So we looking at into account the mechanism of jet stream formation. So what happened in the upper atmosphere? The two opposite type of atmospheric cells or atmospheric cycles are interacting or meeting, and because of that meeting, a thermal contrast get developed between the warmer cycle and the colder atmospheric cycles, and this temperature difference produces the pressure difference, and that pressure difference will produce the fast blowing winds. Okay, so thermal gradient and pressure gradient is responsible for the formation of jet stream. So in upper atmosphere, two conditions get satisfied. One we call as baroclinical curve, get reversed from the ground conditions, and second, it become parallel to the isobar, obtaining a geostrophic balance. Let's go into the detail of baroclinical curve. So in upper atmosphere, the winds are moving faster because of baroclinical curve and flows parallel to the isobar because of geostrophic wind. So let's explore the baroclinical concept. So in the lower atmosphere, if you look at, there is an energy difference between the equator and pole. Equator is heat surplus and poles are heat deficient, and because of the heat surplus over equatorial region, so low pressures develop called equatorial lows, and the polar regions will have heat deficient developing a high pressure. So the wind on the in general should move on the ground from high pressure to low pressure, that is from poles to equator direction. But when we go higher and higher, situation get reversed. Over the equator, along the tropopause, at the height of 18 kilometers, there is a high pressure, and at the poles, at the height of 8 kilometers along the tropopause, there is a low pressure. Opposite condition get maintained. So what is happening? That means as we are moving in the equatorial region upward, low is becoming high, and at the polar region, high is becoming low. So now what happened at the height of around 3 to 4 kilometers, pressure gradient become zeros. Okay, so the wind which is moving from poles to equator gets slowed down, and above 4 kilometers, taken hypothetically, what happened? We are calling this as the area of upper atmosphere. Here now the PGF get reversed. So now in this equatorial region, high is becoming more higher as we go higher and higher, low is becoming more lower and lower. So the difference between the equator and pole is increasing. So now the direction of the PGF get reversed from the ground. It is now from the equator direction towards the polar direction. So now the wind is start following the PGF. That's what in upper atmosphere, wind should be moving from equator to pole. That's what we are saying. It is moving from hotter areas toward cold, and it is reversed from the east surface wind. So what happens if we go higher and higher in the upper atmosphere? So here as the height increases, PGF also grows because high become more high and low become more lower. So the difference in the pressure is growing with the increasing height. As the PGF is increasing, what happened to the wind velocity? That also get increased up. Now increasing velocity make the upper atmosphere wind stronger and stronger. So what we can say, there exists at a global level a thermal contrast between the equator and the pole. So as a result, equatorial heat surplus region is transporting in upper atmosphere heat towards the pole in the form of jet stream. Okay, so this is the one fact. The moving wind came into account with the second force. The second force called as the Coriolis force, that itself rotation of the earth. We know total wind is a byproduct of three forces: pressure gradient force, Coriolis force, and the frictional force. In upper atmosphere, wind is moving from equator towards pole because of energy difference, thermal contrast. Okay, but once the wind is gaining the speed, then it encountered with the second force, deflection by the Coriolis effect. So in the northern hemisphere, deflection towards the right, in southern hemisphere towards the left due to Farrell's law. But in upper atmosphere, the amount of frictional forces are nearly zero because there is no resistance has been active here. So we already know what happened to the Coriolis force in the upper atmosphere. So in upper atmosphere, it is stronger because the wind is, as the height is increasing, PGF is growing, velocity of the wind is also becoming stronger and stronger. We already know Coriolis force is directly proportional to the velocity of the wind. So stronger the wind, more will be the Coriolis effect. And what does it means on the ground? More will be the deflection in northern hemisphere towards the right southern hemisphere toward the left. So the wind which is moving from equator to poles in northern hemisphere, they're turning rightward like this. So the entire direction obtained is from west to east. In the same way, in the southern hemisphere, deflected toward the left. So the jet streams around 30 degrees start moving from west to east, and similarly when at 60 degree also start moving from west to east. So this is the reason why most streams flows in the west to east direction. One more impact it can have, the increasing Coriolis effect with increasing height. You see the amount of deflection is increasing. Okay, at one particular height, PGF become equal and opposite to the Coriolis force. So you can see at the some height, PGF become equal and opposite to the Coriolis effect. So then the resultant wind cannot cross the isobar, they start flowing parallel to the to them. So such winds become a geostrophic wind because of a geostrophic balance has been obtained. I hope you got this clarity. So now there are certain locations this situation get obtained. It could be any height between 14 kilometers. For example, at 30 degree latitude, at the 12 to 14 kilometers height, first balance has been obtained because of interaction between ferrule cell and the Hadley cell. Second, at the 60 degree, ferrule cell interacting with the polar cell, that producing a polar jet stream at the height of 8 to 10 kilometers. So at these two latitude and these two heights, you have a permanent jet stream, and both are moving from west to east and covering the entire globe. Two permanent jet stream you can see, because here both the conditions are satisfied. One is the baroclinical curve and geostrophic. So what in short we can say, why the subtropical westerly jet stream develop? Answer is very simple. Due to the interaction between the warmer Hadley cell and the relatively cooler ferrule cell. Here not only the pressure gradient difference is high, but also it is maintaining a geostrophic balance, and they start flowing parallel to the isobar. So it's moved from west to east, and it is called a subtropical westerly jet stream. But at 60 degree, you know, the colder polar cell meeting with the a little warmer ferrule cell, that produce polar jet stream, and the thermal contrast here at 60 degree is more powerful than at 30 degree. So the polar jet stream is whatever is produced at 60 degree north and south is more powerful, more stronger than the subtropical westerly jet stream. So it might be asked to which jet streams are more powerful and more stronger. Answer is what called the polar jet stream powerful. So that is a reason for westerly jet stream and the what? Polar jet stream formation. More temperature the contrast between the opposite type of atmospheric cells, more powerful with the jet streams. I hope you got it. So general, what we can conclude now. So jet streams are produced at those areas, okay, where there are meeting of two opposite type of winds or atmospheric cycles or air masses. So in generally it is moving from hot areas toward cold. In general in the world, equator towards pole, and second, due to Coriolis effect, deflection towards the rightward. So concluded this. At regional level also, some temporary regional seasonal jet streams exist. Example is tropical easterly jet stream over India at 15 to 20 degree north exists in the month of June till September. What is the reason behind its occurrence? Reason is simple, that in the summers, Himalayan Tibetan zone behave like a heat engine, and this heat engine is so much, the amount of the ice on the third pole get melted and reduce the heat ice cover and increase the temperature by 2 to 3 degrees Celsius more than the surrounding region. So as a result, Himalayan Tibetan zone low pressure get intensified. So and that pushes the westerly jet stream away from India above the Tibetan plateau. So more and more insolation received by Himalayan Tibetan zone, and this heat engine become more and more get activated. When this situation arises, So Himalayan Tibetan zone become hot area, and south of the Indian Ocean, south of the equator, is the cooler water body. So now the jet streams start moving from the Himalayan Tibetan zone towards south in ocean. So in this process, in northern hemisphere, what happened due to Colles effect, it turned towards right, and the right here is east to west flow is being attained. That is the reason why the tropical easterly jet stream uh, is flowing east to west actually, and this season is in summer, June till September, and the role of this jet stream is it welcome the sudden arrival of southwest monsoon over India and causing good rainfall, and it flows at the height of around 14 kilometers, maintaining a low pressure or cyclonic conditions over India that attract the southwest monsoonal. Similarly, African easterly jet streams get developed in the summer season that flows at the height of 3 to 5 kilometers, move from Sahara deserts towards the West African coast. What is the reason behind its formation? Same reason. During the summer, the world largest hot desert, Sahara desert, get warmed up, and the warm ocean, warm area produces the jet stream in upper atmosphere that moving towards the south of the Atlantic Ocean. Okay, so when this process, it will attain a geostrophic balance around 10 to 15 degree north latitude, and in the northern hemisphere deflection towards the right. So it again moving from east to west here. Now third example is the what called as Somalian jet stream or cross equatorial jet stream or flindlanter jet stream. So it arises due to the heat difference between Madagascar and Ethiopian. So now there is one more jet stream is been found which is important for us in the stratosphere, that is called polar stratospheric jet stream or polar night jet stream. So what we can conclude, jet streams are not only found in troposphere, it is also found in other layers of Earth atmosphere like stratosphere, mesosphere and thermosphere, but it's not much important. Only what is the important among the other layers is polar night jet stream or stratosphere, and which itself arises due to which reasons? Polar vortex movement that we will be exploring in the slide. So polar night jet stream, which exists at the height of 30 to 50 kilometers in stratosphere because of polar vortex movement. So we have to know what is polar vortex movement. So over the poles at the height of 8 kilometers, there is a low pressure centers developed. So the counterclockwise motion is being observed here. So why does it happen? Because in the ground there is a high pressure, at the height of 8 kilometers is low pressure. So air from all these sides in the tropopause try to fill this low pressure. When air start moving with a great speed, that's called polar vortex movement. Now the air which is coming from all sides to fill this low pressure or polar tropopause, so they push either towards the stratosphere or pull towards the ground in the polar region. So at the ground it maintains the polarized. In the upper atmosphere, above the tropopause, it enters into stratosphere and maintaining at the height of 50 kilometers or stratospheric polar night jet stream. So more technical reason is why polar vortex movement take place. Here is the science behind it. You know, total angular momentum of the earth remain constant, which include the land plus the air together. You know, at the equator, the land is moving at a greater speed, but at the air movement is nearly zero. Okay, so that total angular momentum remain constant at all the points when we are moving from equator to pole. As we move poleward, what happened to the velocity of the land or the earth? It is decreasing. So the poles become nearly zero, and when the land becomes zero, keeping the angular momentum constant, what is happening to the air velocity as we are moving from equator to pole? It is increasing. So the air becomes stronger and stronger as we move from equator to poles, because angular momentum is being transferred from the land to the air as we are moving poleward. So at poles, what happened? At poles, the land velocity, the earth moving rotational velocity is zero, but entire momentum is transferred to the air. So the air velocity attains the maximum, keeping the angular momentum constant. So that is the reason at the polar region at the height of 8 kilometers, speedy movement of air has been observed that maintain the low pressure, and this movement called as polar vortex movement, and that is causing the high pressure maintenance on the ground areas and stratosphere jet stream. So this can explain the process of ozone depletion. That's what ozone depletion increases in winters, because this formation is in the winter seasons. So what are the other roles of jet streams? So now jet stream can explain atmospheric circulation system on the ground by forming the convergence and divergence centers. Suppose this is a jet stream which is moving up and down because height varies. When it is at 4 kilometers height, it is causing divergence. When it is at the 14 kilometers, 10 to 14 kilometers height, it is causing convergence on the ground. So because of this convergence divergence series is produced on the ground as well as in upper atmosphere, so air starts circulating between two convergence centers and two divergence centers. Suppose the convergence center on the ground is attracting the air from outside. Divergence centers on the ground is producing the downward or outward flow of air. So that means from divergence, air goes to convergence center. At convergence, there is a rise of air. At the upper atmosphere, there will be divergence. So the divergence air push the air away from it. It's attracted by the convergence center. So at the upper atmosphere, convergence will push the air downward towards the divergence center. So this maintains the atmospheric cycle, and this cycle can explain you the local weather condition of any area. Suppose this is a jet stream which is moving up and down, causing convergence and divergence. So this is a divergence center maintaining high pressure, convergence centers maintaining at the ground low pressure. So what is the impact of this convergence and divergence center? So example, divergence centers maintain high pressure center. High pressure center means anti-cyclonic condition or atmospheric stability, and the atmosphere remain clear with the cloud, no clouds have been observed. So dry weather, no rainfall. So divergence is this. What the convergence can make? It will create a cyclonic condition, means air start rising upward along with moisture, causing atmospheric instability. Cloudy weather condition, rainfall, wet condition, thunderstorm activity get increased over the convergence or low pressure center. Now it can also explain the formation of Indian summer monsoon arrival, withdrawal timings, as well as the amount of breaks. So during the summer season, when Himalayan Tibetan zone get heated up, it has two impact. First, withdrawal of westerly jet stream from India and the establishment of tropically jet stream over India at the height of 14 kilometers. When this happens, so this will maintain a cyclonic condition over India, or low pressure over India, and this will attract the southeast wind from the southern Indian Ocean. On crossing equator, southeast trade will become southwest monsoon. When it picks up moisture from Bay of Bengal and Arabian Sea, and these winds are entering over India because attracted by the cyclonic condition over it and causing good rainfall, and this is responsible for 75% of total rain of India. And we can say that bursting of southwest monsoon is totally depending on incoming of tropical easterly stream over India. So this is a monsoonal cycle of India. So till the tropical easterly jet stream is maintained over India, it is maintaining southwest monsoon wind causing good rainfall. Okay, so whenever the breaks in southwest monsoon arise, the reason is westerly jet stream enter in this side, and this tropical easterly jet stream is not active. Now it can also explain the winter monsoon and western disturbance over India. Example is that during the winter season over India, the westerly jet stream or subtropical westerly jet stream is moving towards equator, established around 30 degrees and hit the Himalayan Tibetan zone, divided into two branches. One branch goes south of the Himalayas up to the Vindhyachal, and the one branch goes north of the Tibetan plateau. So the branch that goes south of the Himalayas is affecting India in two ways. First, south of this westerly jet stream, it's creating anticyclonic condition, push the air downward and maintaining high pressure, and because of that outward flow of air or offshore winds get established. Already northeast monsoonal wind get established over India are also called retreating monsoon. So generally remain dry, but it picks up some moisture from Bay of Bengal, hit the southeast coast of India or Coromandel coast and Nicobar Island, cause a rainfall in this area. Okay, and rest of the India does not receive rainfall in the month of October, November, December, January, or winter rainfall, except the southeast part of India. But north of this southern branch of westerly jet stream, creating a cyclonic condition. This will attract the westerlies wind, which flows from Mediterranean Sea, and 2 to 3 waves in a month it can hit in the winter, that is pre-monsoon and post-monsoon, and cause rainfall. And this is the fun. You can explain in this way. I hope you got this. What is the other role of jet streams? So it is dispersing the air pollutant all across the globe. So in this way, even ozone depleting substance is pushed towards the polar jet stream, and then from polar night jet stream enters into stratosphere. So that resulting into ozone depletion. So jet stream can explain ozone holes over the Arctic and Antarctic region and widen up. Because of the winter, this entire transport system and the jet stream movement is very, very strong. So which jet stream are responsible for ozone depletion? Answer is polar night jet stream. Even Somalian jet stream can make Indian monsoon, southwest monsoon strong actually. Okay, when Somalian jet stream is weak, Indian monsoon also get weakened actually. So this is the impact of the jet streams. You can also explain the extreme weather events like cold waves, heat waves, cyclonic disturbance, etc. You know, the polar jet stream at 60° north and south, it's moving more zigzag because of climate change. So as a result, allowing the warmer air from tropics to enter in higher latitudes or colder airs of Arctic and Antarctic into the lower latitude. So because of more meandering, your polar jet streams are allowing the polar vortex to become weaker and weaker. As a result, jet streams are getting what? More zigzag flow, and that is increasing the events of extreme weather events. We can see the role in the tropical cyclone also. So tropical cyclone incidents have been increasing and intensified. This for today. Thank you all of you. Bye-bye.